Okay, so today we're going to be wiring a receptacle. Will you grab me a switch, somebody? Let me borrow your switch. A single pole switch and a light in a commercial setting with metal boxes. We're going to be using single conductor wire and feeding through. I've selected blue as a hot. The color can be red or black, but your white and green are always going to be your ground and neutral. I am not going to be able to ground the boxes because I don't have ground screws, but that's something that needs to be done whenever you're doing wiring the metal boxes. You put a green ground screw in here and wrap the ground around it. But for today's purpose, we're just going to be doing the basic circuitry and wiring. We'll make up the grounds to the devices, and that's it. So I'm going to come in from my simulated feed from the panel with a hot, neutral, and ground. And I'm going to be wiring my receptacle in this box, my switch in this box, and then a light in the last box. So I'm going to come up, I'm going to leave about 6 inches of wire sticking up, which is per NEC code. I'm just going to cut off a little here, a little wire sticking out that we're going to make up to a cord to simulate the power feed. From here, I'm going to go to my next box. And about 6 inches of wire there. This box is going to have a switch in it. So what do I need to do with this neutral? I can either cut it here and splice it and make it through, or I can pull it straight through since this is a commercial application and not worry about it because a switch never gets a neutral. So I'm going to pull it straight through in this case and not cut it. You may want to leave a loop when you're doing this type of work so you do have the ability to tap into that neutral in the future if you need to. In a commercial setting, these boxes may be 50, 60 feet apart, so you want to have a neutral maybe in every box. So I'm just going to curl that up and leave it in the bottom of the box. I'm going to cut my hot and ground. Then I'm finishing out my wiring to the end here where the light is. The things that get neutral in this wiring scenario are the receptacle and the light. Switch, all it does is break the hot. So it's got a hot coming in and a switch leg going out to the light. Okay, it either opens or closes that hot. Okay, so we're going to start with my receptacle wiring on this end. I'm going to pigtail my grounds, and I'm going to show you how to do that. A pigtail is when you can make two wires turn into one. I only have one green screw on my receptacle, so I need to make these two wires into one wire. And the way I do that, one of y'all got a red wire nut? Red wire nut, thank you. So I strip about 1 1/8 of wire, 1 1/4, something like that. And I put another piece about 8 inches. I like to leave it a little long so I can cut it off. Then I'm going to put the three together and I'm going to twist them with my pliers in a clockwise direction. I'm going to cut off the little excess that I may have, and I'm going to put a wire nut over it. The reason I do it in a clockwise direction is because I tighten my wire nut in a clockwise direction. Okay, so now I like to tell my students this is where it gets simple. I've got 5 wires sticking up and I've got 5 screws on this device. Very easy. So when I'm looking at my receptacle, I can go left side is white, right side is hot. But what you want to remember is the silver screws get the neutral. The more brass colored screws get the hots, okay? And the green screw gets the ground, obviously. So I'm getting these ready, these wires ready to make up to the device. I want to strip probably not quite 1 inch, maybe 3/4 of an inch of insulation off of each one. And for today's purposes, we're just going to leave the devices sticking out of the box because that's how I check my students' work anyway. We do not attach them to the box with a P-ring. We just leave them out. So I'm going to then bend a hook on each one, and that's what these little holes in your stripper is good for at the top. So you bend a small hook in each. Alright, I'm going to make them up to my device. So I'm going to wrap the solid wire around the screw in the direction that I'm going to tighten the wire. So I've got the long side on the left side because I'm going to tighten the screw in a clockwise direction, and that will actually tighten the termination. If you do it in the other direction, it will actually open the hook some, and it's not as good of a connection. So then I'll do my two neutrals on this side. This device actually has a little tab that you can stick that wire under and just pull it, so you don't have to necessarily pinch it like I did on the ground. Some brand manufacturers do not have that. I never teach my students to use the stabs in the back for 14 wire. Number one, I always use 12 wire, and number two, I'd like to teach them the best way to make up a device, and this is the best way. You can also pigtail these neutrals and hots if you desire, and just leave one coming to the device, which is done a lot of times in commercial applications to make it an easier trim job. So again, I'm going to make up the hot side. Again, leaving the long wire on the left side of the screw so it tightens the loop when I tighten it. I'm going to go ahead and pinch this one. I've got a little wire sticking out there, just a little easier. When you do this, do not just put the wire on the screw and leave it to tighten later. Do that on each wire as you do it. That way you have it done. You'll forget that. You'll leave them on there and then you'll forget one or two, which is a very bad situation. Okay, now we're going to make up my switch. So I have a single pole switch. It has two brass screws and a green screw. So I'm going to have to pigtail my ground. And the reason a switch has to be grounded, a receptacle has to be grounded, because it has that center, that grounding plug on the bottom, that receiver of a ground from the plug. So that's definitely something you have to do with the receptacle. The only reason you ground a switch is because it has a metal yoke. And the only shock hazard you have out of a switch, being that it's usually a plastic plate, it could be stainless in a commercial type environment. But you have metal screws that go in here, and you could theoretically touch your door jamb, touch that screw, and that hot wire. A hot wire could be touching that yoke and energize. So there's a potential of shock there, a very small one, but still. So we have to ground these. You'll see a lot of residential electricians that do not ground their switches. That is not a good practice because of that reason. I don't want to be responsible for the freak accident of somebody getting shocked on a device plate screw on my work. I think I need that tripod, but I'm a pretty messy worker, so you gotta watch yourself around me. So again, I twist these wires, and for my students' sake, you notice how I'm holding the pliers. I'm not doing this, okay? I'm coming over the top and twisting like this. You want to kind of loosely grab it initially and get the wire started, and then kind of tighten your squeeze on the handle as you get a little towards the end. Give me a red one. We have big blue over there, but that's not needed. So, in this box, I now have my, and once again, in the commercial, you need to ground the box, so you'd have one of these wires wrapped around there or an additional pigtail coming into that ground to make the box grounded. But I do not have ground screws, so now I've got 3 wires and 3 screws. Very simple, right? So obviously, the blue wires go on the brass and the green goes on the green. Now, a good common practice that I have not seen on most of the videos I've seen on YouTube demonstrating this is you have a top and bottom of the switch. It actually says off and on here. So that would be on, that would be off. I teach my students to come into the top with the hot and out of the bottom with a switch leg going to the light fixture, strictly because that's how you have a disconnect set up. The line comes in the top and the load comes in the bottom. A lot of the videos I've seen will tell them to come into the bottom. I don't like that practice, and I don't think local electricians do it that way. So you can go behind an electrician and kind of know that where he's got the hot, which is important. So the hot on the top. And the switch leg or the wire going to the light on the bottom. If you have this switch upside down and in one position, it tells you no. That's the word on upside down, N-O. So you'll know you have it wrong. And obviously if you see off and it's upside down, you'll know you need to turn in the other direction. Most of the grounds on devices are the worst connection on here, and they should be the best, but I don't make these. Okay, so now we're done with that. So we're gonna move on to our light fixture. And all I have here are these porcelain keyless, little cheap closet light, attic light type for my students. So what do we notice about that? It's ceramic, so guess what? It does not get a ground. But we leave this ground in this box because if we install a plastic light or a fixture without a ground, and the homeowner comes back and wants to change their fixture to a nice brushed nickel fixture or something like that, it's going to have to be grounded. So you want that ground in there for them to use. You don't want to get rid of it because it will be used in future retrofits. So I stripped those a little long and cut them back a little. And we're going to put hooks on these too because these type of fixtures have screw terminals. As you can see, a silver and a brass. So we go silver with the neutral. And we want to wrap the wire in the same direction, just like we did the devices. And a brass hot. We have a cord here, back there. Hand me that. So what I do in class, I'll go ahead and energize these little projects that I have my students do. And we want to see them in action work. Some yellow wire nuts. Give me 3 of those yellow wire nuts, please. Thanks, sir. Okay, so when we make up a stranded wire to a solid wire, the way we do that, we do not twist them with the pliers like you saw me make up the solid wires. We just align the stranded and the solid, the ends equal together, and you lightly start the wire nut over so you make sure you're not pushing that stranded wire back down that solid wire. And that's what will happen. It'll just push it down and it won't connect. You want to tug on that stranded wire on each connection and make sure they're good. This is a very easy way. It's very easy to make a loose connection with making a stranded and solid wire up together. There's a box over there by that whiteboard, the furthest one. There's a little plug tester in it. Looks like a little yellow plug-in module. Is that in there? Yes. Okay, so we're all done here. I know you can't see the whole project in one piece, but that's it. So we're going to plug it in. I'm going to just double check, make sure I don't have any wires touching here. Want to hand me that plug? I'm going to go ahead and plug my plug tester in here because these wires will be hot in just a minute, and I don't want to get my hands on those screws. So right now my plug tester should work. And as you can see, the outside light's on. In this particular model, the 2 outside light means correct wiring. All right, so that's good. So I'm gonna flip my switch and energize the light fixture. So we have a complete, properly wired system there. All right.